Here we go. 2-1. Go ahead and get your learning goal down and your title, Linear Equations and Slope today. So if you're in the Math Academy this summer, we talked about those days where we review like a whole half chapter of algebra in a day. That's today. We get to review like a half a chapter of algebra in one day. It's awesome. All right, here we go. Start up here. Talk about some definitions. First is linear equation. And you don't have to write these out of your book or anything. You can just follow along with us. But the definitions we need to go through, make sure we understand linear equation. What do you think of when you hear linear equation? What comes to mind? Yeah?
Y equals mx plus b.
Y equals mx plus b, which is actually slope-intercept form over here. And we'll go into that more detail here in a minute. So slope-intercept form, that does give us a linear equation. Anyone else? What's a linear equation look like when you graph it? Line. Okay? Line. Linear. All right? Makes a straight line when you graph it. Okay. So y equals mx plus b is slope-intercept form. You're given m, which we call slope. Now slope has a lot of different names for it. Okay, so if I'm defining slope, let me kind of zoom into that there. If I'm defining the word slope, tell your neighbor another name for slope besides m.
Rise over run.
Okay, here are a bunch of them. So I heard some good ones out there. Cody?
Rise over run.
Rise over run. All right, that's usually one that comes out. Rise over run. Rise over run is the... We'll go for it. Yeah. Rate of change. Hey, let me add that one over here. I'm going to put that over here. Slope is rate of change, or rate. Let's say our rate. Okay? If you want to write up change, you can. Rate of change. M, rise over run. Rise over run is the same thing as change in y, or delta y. Delta, you kind of have this thick line, this triangle, delta y over delta x. Change in y over change in x. And there's actually a formula we use for change in y over change in x. Anyone know what that is? Has y's and x's in it, yeah.
y2 minus y1 over x2 minus x1.
Good, yeah. y2 minus y1 over x2 minus x1. And obviously we call it slope as well. All right. It seems pretty comprehensive right now. Okay. We may call it some other names, but all of those things are slope. That's what slope has, all those different names. Just like your parents may have a nickname for you. Okay. You know, your friends may have a nickname for you, and you go by all those names. Okay. Some people that don't like you may have names for you. That's not good. Okay. Hopefully you don't respond to those. Okay. There are names here. Each one of these have names. Okay. And these names go with different types of problems. Okay. So you have to know when to use each of these names. Okay. Or each of these items. All right. Now, y-intercept is another part of our equation, y equals mx plus b. So we've got slope. Okay, we know how to find that. We actually have a formula that we'll use quite a bit. Okay, but b is called our y-intercept. And our y-intercept is where it crosses the y-axis. So in a picture form, you may think of a y-intercept, if this is your xy axis here, you may think of a y-intercept as this point right here. It's where it crosses the y-axis. That point is our y-intercept. Okay. Another way to think about it, the y-intercept is when x equals what? Chance? Yeah. When x is 0, you get a y-intercept. Like this coordinate right here, where it crosses the y-axis, that coordinate has the ordered pair 0 something, depending on what that, if that was a 2, it'd be 0, 2. Okay, that would be our y-intercept. It's when x equals 0. In an equation, if I gave you the equation y equals 4x plus 3, The y-intercept is when x is 0. So I end up putting in 0 right here. That whole thing disappears because 4 times 0 is 0. Y equals 3. That would be where it crosses the y-axis. That's why B is our y-intercept. Okay? The x-intercept. Tell your neighbor what an x-intercept is.
Where it crosses the x-axis.
All right, time's up. X-intercept is where it crosses the x-axis. And so if we relate it to y-intercept, x-intercept is where it crosses the x-axis or when y equals 0. Okay, so once again, this would have a coordinate. Let's say this was -2. The ordered pair there could be -2 and then y is 0. Okay, if I had the equation y equals, now this isn't necessarily the equation for this, but y equals 3x plus 2, my y-intercept is when x is, or excuse me, my x-intercept is when y is 0. So I'm going to put that 0 in here and solve. I get 0 equals 3x plus 2. 3x equals -2. If I subtract 2 from both sides, divide by 3, x is equal to -2 over 3. The other way around, my bad. Okay. Now obviously that is not that x-intercept, right? Okay, but that's what would it be in an equation form. Any questions there? Now how many of you have reviewed something that you had kind of forgotten? Right there. How many of you remembered all that? You're like, dude, I knew that. Like I could have went up and taught that, McCoy. How many could have taught it? I just want to know who I need to call on to teach when I... Okay, good. So I have a few people that I can call to teach now. A linear function. Since we know most of this stuff, I'm assuming we know what a linear function is. Tell your neighbor what a linear function is.
It's a function that is linear out of points. Same.
Okay, time's up. What's a linear function? Sam. Okay. So is a linear equation. What's the difference between a linear equation and a linear function? You want to take a guess? No one else knows. Might as well guess. Yes, we found something people don't know. Hey, this is a function. F of x equals mx plus b. Hey, now we're in function notation. F of x is the same thing as what?
Y.
Y. It's just different notation. You can put input here, just like we did this last chapter, where you put something in for x and that goes over here. So I could say, hey, if f of x equals mx plus b, solve when x is 5. So you do f of 5 and you plug in 5 over here. M times 5 plus b. Hopefully you'd actually have numbers. So let's pretend for a minute m isn't m, and let's say it's like 2. Okay, so you'd have 2 here. Okay, so you'd have 2 times 5, and let's pretend for a minute b isn't b. Let's call it, what do we want to call it?
5.
3. Okay, so now that's 3. Okay, so when you plug in f of 5, that's actually 10 plus 3, or 13. If we would have used 10 plus 4, that would have been 10 plus 4. Good, buddy. 10, 4? Okay, you guys didn't get it. Okay, but f of 5 is 13. That means you would have the ordered pair 5, 13, right? Function notation allows you to use functions to find, using given inputs to find the output. Use functions to put the given input in to find an output. Okay, how many knew that? Okay, you did not, because you wouldn't raise your hand a while ago. You didn't know it. You acted like you knew it. Now you know it. How many know it now? How many are like, oh, I already knew that. I just didn't know that I knew that. Okay, yeah. So, all right, that's why we review it. All right. So we're not going to read about the horizontal, vertical, perpendicular, and parallel slopes, all that stuff. But what I want to do is just make sure we're clear on some things about slope. Okay, this is a line rising from left to right. This is a line falling from left to right. This is a line
Can't see.
that you can't see. So you have to guess, but Nick can see it. He's just saying he can't. Okay, but
Oh, I can see it.
yeah, you can. But we'll show it later. Okay, so now this line right here, is it a positive or negative slope? Tell your neighbor.
Positive.
Okay, tell him why it's positive.
Because it has slope. It's going up.
Okay, time's up. Why is it positive? Yes, Eli. Okay, a guy could run up a line, or another way of thinking is From left to right, it rises. It's like reading a book. You read it from left to right. You read graphs left to right. You read this graph like a book, left to right. This one is falling from left to right, so it's negative. As Eli pointed out, a little dude, if he's standing here, he'd be running uphill on a positive slope. A little dude standing here, he'd be running downhill on a negative slope. Okay? All right. Falling, yeah. Okay, this line right here. Tell your neighbor which axis it crosses.
That y-axis.
Y-axis. Okay, the y-axis. This line right here crosses the y-axis at 1, 2, 3, 4, and 5. Okay? It crosses at 5. All right. This line is called, is it vertical or horizontal? Horizontal. So those of you who don't know what horizontal is, remember horizontal. Okay? Horizontal, you think horizon. You could think H has this little line like that, which is horizontal. But then again, it also has two vertical lines, so that doesn't help. Okay? The horizontal. All right. There's horizontal. Horizontal crosses the y-axis. Therefore, it's a y equals equation. In this case, it's y equals 5. Okay? Anytime you have only a y equals equation, it only crosses the y-axis. In this case, this equation, let me zoom out a bit. These two equations over here, they cross both axes. They cross the y and the x. Therefore, it's a y equals mx plus b equation. Both of these. It just so happens that in this case, m is negative. In this case, m is positive. Here, there's no x because it doesn't cross x. All right? How many of you knew that? Of course you did. All right? This one right here. Can everyone see that?
Mm-hmm.
What type of line is that one? Vertical. 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 It's a vertical line. Vertical lines go up and down. Like if your buddy says, hey, you have no vert, it means you can't jump, dude. Okay, that's not good. Unless you're, I don't know what you do when you don't jump. I've got hops. Okay.
You can't reach like
1, 2, 3. -3. Okay, -3. It crosses the x-axis. This is an x equals line. It's only x equals. Okay, so note the difference. If it only crosses x, it's x equals. If it only crosses y, it's y equals. What's the slope of this line? Tell your neighbor.
0.
Okay, how many say it's undefined? How many say it's 0? How many say they're not sure?
Which graph?
This graph right here.
Oh, they're talking about the one down there. Oh, that one?
No? How many say it's undefined? How many say it's 0? Okay. This is a 0 slope. Now, if you think about it, y equals mx plus b. If I put 0 in for, well, I know the y-intercept is 5, so I have y equals mx plus 5. If I put 0 in for the slope, what happens to this x?
It's 0.
Yeah, 0 times x, or 0 times x is 0, so we get y equals 5. Okay, that's how we get that equation. What's this slope?
Undefined.
This is undefined slope. So here, m equals 0. Here, m equals undefined. All right? When you start thinking about rise and run, remember slope is rise over run. From this point right here to say this point right here, what is my rise?
0.
It's 0. I rise 0. How much do I run?
3.
Yeah, it looks like 3 from that point to that point. What's 0 divided by 3?
0.
0. If 0 is over the fraction bar, the answer is 0. If it's over the fraction bar. Now, I will guarantee at some point you're going to want to know this year. If 0 is over the fraction bar, the answer is 0. That is a 0 slope. Okay? Word over starts with 0. Actually starts with O, but we'll go with 0. Okay? In this one, if I want to go from this point to, say, this point, how much do I rise?
3.
I rise 3. How much do I run?
0.
0. If 0 is under the fraction bar, it is undefined. Okay? Please try to remember that if you didn't know that. So all these little things that I expect you to just know, we're hitting on right now. Now, how many knew all that? How many needed a bit of review? Good job. I'm glad some of you needed a review. Makes me feel like I'm doing something. All right.
Doing your job, right?
Thank you. I appreciate it. Okay. Very good. Tell your neighbor something you've learned so far. Let's talk about this. A couple other forms I want you to have down. Okay, we talked about slope-intercept form. This is standard form. Now, you'll use standard form a lot this year when we do systems of equations, especially systems of 3-variable equations. You need to know ax plus by equals c. You need to know that that's called standard form. You need to understand that in standard form there are some rules. Anyone remember the rules? A, B, and C cannot be
0.
Yeah?
0.
No.
1.
They cannot be fractions unless it's a whole number. Whole numbers are technically fractions, but or maybe we just don't say they cannot be. Why don't we just say A, B, and C must be whole numbers. And A must be, anyone know? Eli? Yeah, greater than 1, which we call A. Cody?
Whole number?
Yeah,
No.
true.
No, natural number.
It is a natural number. Okay. A must be positive. Now I am thinking of your test, and I am thinking, I can see the problem right now. I can see exactly where it's at. I'm not going to write it down. Okay?
Oh, man.
But I don't know how many students missed that. This is on your test. Dude, you're going to be tested on this. And we don't touch on it any more than this until chapter 4 again. Okay? A, B, and C. A, B, and C must be whole numbers. A must be positive. Actually, we'll do a little lesson on it, but okay. How many remember standard form from algebra? How many remember it from this summer? Okay. All right, slope-intercept form. You have that. There's one other form we use, point-slope form. Point-slope form is helpful to write an equation given a point and the slope, hence point-slope form. If you're given a point, for instance, if you were given the coordinate 3, 2, and the slope, m equals 1/2, then you could easily write an equation and put it in standard form using point-slope form. It would be, hey, write the equation of the line that goes through the coordinate 3, 2 and has a slope of 1/2. We'll do that today. Okay, that's when you would want to use point-slope form. Some of you did that without using point-slope form in algebra, and we'll talk about that as well today. But I personally think it's a quick form if you know how to use it. Notice there's an x or an x1 and a y1, but there's no x2 and y2. There's just an x and a y. We want our end equation to have y equals mx plus b. Notice in that end equation, there's an x and a y, the same x and y you see here. The m is the same m. Okay? The y1 is this. The y or the x1 is this. Okay? So we put all those things in and we manipulate our equation. If we did that here, we'd have y minus y1 or y minus 2 equals m times x minus 3. And notice I use parentheses a lot anytime I'm substituting. Y minus 2 equals 1/2 x 1/2 times the quantity x minus 3. We distribute. Y minus 2 equals 1/2 x minus 3 halves. What do you do now? Get its slope-intercept form?
Add 2 to each side.
Add 2. So y equals 1/2 x. What's 3 halves plus 2?
3.5.
7 halves. What's 2 in terms of halves? How many halves are in 2?
4.
4 halves, right? You just multiply 2 by 2, you get 4 halves. So if I add 4 halves to this side, what do I get?
7 halves.
If I add 4 halves?
Mm-hmm.
Yeah, right? Negative 3 halves plus 4 halves?
Oh, it's 1 half. 1 half.
1/2, right?
Yeah.
Yeah, that's what you said. But not. Okay? Okay, 1/2 x plus 1/2. Okay? All right. Slope-intercept form on it. Now we'll go through another one like that here in a while. Let's talk one last thing. One last thing has to do with these two lines. And this is like the coolest thing. I went through, I knew we were doing this today, and I saw this summer. We had, back in the day, we had these things called transparencies. How many know what a transparency is? How many know what an overhead projector is? They're awesome. You know, they shoot light through them, and you put things over the top, and you can see through them. See, they're like see-through. I know, right? And yeah, it's crazy. Okay? Now, we used these a lot when I first started teaching, but this is a transparency. And this line right here, I've covered up one of the letters because I want to just call it line B. There's actually 2 lines there. You can kind of see them. But this line right here, this line, if you just start thinking about the slope of it, that line right there, everyone knows as what?
Y equals x.
What's the slope of it?
0.
0. Okay. This line right here has a slope of what? Undefined. What's the slope of that line?
5.
How much do we rise from here to here?
5.
5. We run?
1.
So slope of 5. How about now?
2.5. Or 2. Yeah, 2.5.
Okay, so 5 halves, which some of you are saying 2.5. So we had a slope of 5. We had then a slope of, well, we had undefined, I guess. Then we had 5, and then we had 2.5 all of a sudden. Okay, how about now? Oh, that's the 2.5. I'm sorry, there.
5/3.
5/3. Now 5/3, some of you have a hard time if you don't see decimals, so that's about what? 1 and
1 and 2/3.
it's 1 2/3 or 1.666. Okay, we just say 2/3. Okay, how about now? We had that, right?
1.
1.
Yeah.
So rise 4, run 4. Okay, 1. How about now? Rise 3, run
4.
Rise 3, run 4. How about now?
Rise 2, run 4.
Rise 2. What are we getting close to?
0.
0. So as that line starts flattening out, what's happening with the slope?
It's getting small.
Yeah, it's getting smaller, right? The flatter the line, the smaller the slope. Now, how many knew that? Of course, everyone knew it. Okay? When we get to here, we got 0. Okay. From there, what happens when I keep turning it?
It's -6.
It's a negative slope now. Now, those of you who stopped looking up here and you went down and looked at your paper, or you just kind of stopped, you missed the whole point of doing that is make sure you have a conceptual understanding of slope. You're at undefined, you're decreasing until you get to 0, and then once you get to 0, you keep turning that, and all of a sudden it's negative. Okay? And we keep going until we get to undefined, and what happens again?
It's positive.
It becomes positive. All right, very good. Okay, so from that, let's talk about parallel and perpendicular lines. Parallel slopes, actually, let's go with perpendicular slopes real quick. Perpendicular, so these two lines right here are perpendicular. Okay. What are their slopes?
1.
Everyone agree it's 1 and -1?
Yeah.
Slope of A is 1. Slope of B is -1?
Mm-hmm.
Okay. All right, let me zoom out just a bit.
can't see it.
Thank you. All right. Slope of A and B. So let's twist it a bit more. How about now?
3/4 and -3/4.
Slope of A, so going from, say, here to there, so we rise 3 and we run
4.
4. Everyone agrees 3/4? What's the slope? Drop here, go this way.
-4/3.
-4/3. What do you notice about those slopes? Good, there's opposite reciprocals. Now, how many knew that? Most of us know that. Most of us don't realize, though, that if we multiply the slopes of perpendicular lines, what value do you get?
1
These cancel, right?
or -1.
You get
-1.
-1, yeah. Anytime you multiply the slopes of perpendicular lines, you should get -1. Okay? Now, some of you just go, yeah, they're inverse reciprocals, and that's fine. But to do your check, make sure that they equal -1 when you multiply them. What do you know about the parallel lines? Slopes of parallel lines?
They're the same.
They're the same. They have the exact same slope, right? Parallel lines have the same slope. So if I had that line right there, let me match that up, okay, the best I can. There's a line. I want you to tell your neighbor what the slope of another line is that is parallel to it. Okay, volunteer, what's the slope going to be? Hey, Gabrielle, or excuse me, Cassie? What's that? The same. What is it? 2/4. So 1/2. Okay, so like if I put that line there, okay, and I matched up this point and this point, I rise 1 or run 2, and that's parallel. Yeah? Okay. What would the slope have to be if I want it to be perpendicular? Tell your neighbor.
-2/1.
Okay, so how about that one there? How many got -2? Okay, drop 2/1. Okay, very good. Any questions so far? All right, lesson's about done. I want to try some problems together. Why don't you take a look at your assignment? Okay. Let's look at this side here. The first thing we need to do is we have to check out these problems that have this kind of stuff, words and pictures, and you got to read, and yeah. So everyone read it. I know. Okay, volunteer to tell me what the slope for student 1 is. Maddie? 1. How many agree? Slope for student 1 equals 1. Okay. What's the slope for student 2? So here we just rose 1, ran 1. Student 2, Ethan? 3. So we start here, we rise 3 and run 1. Good, yeah, 3. How about slope for student 3? Eli? 5. Okay, everyone agree? The slope's not the hard part. The second part's the hard part. And I think of your test and quiz where I give you a question like this. I say, explain the meaning of the slope. It doesn't mean I rose 1 and ran 1. That's not the meaning. Claudia, what's the meaning?
That he sold one shirt every day.
Good. Now we would say 1 shirt. I like the way that Claudia, I don't know if she did this on purpose, but she's related those two things. Did you do that on purpose, Claudia? Okay, this is called your X or Y. Stay with me. I'm trying to make a connection that some of you have never made. This is called our Y. What does slope mean?
Rate of change.
It's rate of change. It's what over what? Y over X. It's change in Y over change in X. So our slope is in the form of Y over X. Everyone agree? Gabby, you agree? Okay, Y over X. So when I say Y over X, I'm looking at labels over labels. Y over X. Shirts over days. Or shirts, this in math is called per. Shirts per day. Okay, now how many knew that you could do that with your labels? If you didn't know that, that's a key thing, especially when you're dealing with story problems. That's shirts per day. How many shirts? Well, that's my slope. 1 shirt per day. What about the 1 shirt per day? The only problem with Claudia's description is that she was wrong with what they were doing with the shirts per day. What are we doing with these shirts? Jordan? Yeah, we're good. Student number 1 decorates 1 shirt per day rather than selling. Good. So what about student 2? Go and tell your neighbor what student 2 and 3, what's the meaning of those?
She decorated 3 shirts per day.
Okay. Jaron, what do you think for number 2?
He sold 3 shirts. Or he
Decorated 3 shirts per day. Good. How about the meaning for number 3? Gabby? 5 shirts per day. Hey, let me point something out. When you guys get your test back, you guys did really well on your test. And some of you are going to be really bumming, though, because I took off like quarter points here, quarter points there, which add up to, and you're going to be like, that guy's so picky, man. Eli, your dad's so picky. And Eli will be like, yeah, I know. Okay. Hey, yeah, I'm pretty picky, man. When we say sold versus decorated, that's a big difference. I mean, if I decorate shirts if all I had to do was decorate them to sell them, that'd be sweet. I'd just sit there and color on them and say, look, and then they're gone. And I just made some money.
Raise money for a homeless shelter.
Yes.
They had to sell them eventually. I mean, I don't think people just paid them to watch them decorate shirts.
Hey, I agree. Eventually they're selling them. It's very true. However, that's not what this graph shows. Okay? Right? The slope of each line represents the average shirts per day for that student. What did that student do? They finished decorating them to raise money. Very true. Now, we don't know if they sold those per day. We don't, right? I agree. I hope they're going to sell them. I wouldn't pay to watch you decorate a shirt. Okay? Some of you would. Sammy would. So if you guys need money, call Sammy over. She'd give you money to decorate. Watch. Okay, but guys, I am really picky about it. Okay? Because I want you to be exact. I want you to be precise. Okay? So just kind of keep that in mind. I say these little things, but when you think I'm picky, those are the real things you should be taking a lot of notes on. When any teacher, when they get picky like that, you better write that down. Because they're kind of telling you how they're going to grade your stuff. They're going to be picky. All right? Nothing wrong with that. You guys will step it up. I know you will. Okay, number 4. I want everyone to find the slope of the line that goes through those points. How do we find the slope? Jaden? Okay, how many of you used this formula? Did anyone graph the points? You could do that too. It takes a little longer. The whole point of a formula is to make it a little easier. Okay, notice I put parentheses around those because when you're using that formula, I really think you should write 4 blanks like that so you don't mess up. And you'll notice 4, 8, 3, 5. How many said this is x1? The 4. How many said 4 is x2? Okay, how many use this formula? Okay. How many said 4 is x1? How many said 4 is x2? Okay, so I'm going to call it x2 just because most of you called it x1. This is y2. This is x1 and this is y1. Now, those of you that want to erase, don't erase yet. The whole point of me doing that is to show you that it doesn't matter. I'm going to put 8 in for y2. I'm going to put 5 in for y1. I'm going to put 4 in for x2, and I'm going to put 3 in for x1. Notice my 1s have to go together in my 2s. Okay? And then when I put them into my equation, I get 8 minus 5 is 3, and that is 1, so I get a slope of 3. How many got 3? Those of you who did the other way, did you get negative 3 over negative 1? Yeah. And negative 3 divided by negative 1 is?
3.
Positive 3. You would have had just these flipped around. You would have had 5 minus 8 and 3 minus 4, which would have gave you that if you went the other way. And that's okay. Just note that it's 3. Still positive 3. Okay. Any questions there? Okay, let's move on. Number 8, find the equation of a line that contains each point and has the given slope m. All right, tell your neighbor why number 8 is such a piece of cake. Is number 8 a piece of cake? Claudia? Yeah, because x is 0. And those of you really paying attention today, you'll know when x is 0, that is your... Go ahead. Okay, what do we call this point? When x is 0, what do they automatically give us? It's our y-intercept. Think of your graph. When x is 0, that's on this line. If I have it here, that's the ordered pair, 0, 2, right there. Okay? That line, that's our y-intercept. That means this point is automatically b. You love it when it says x equals 0. That means we know b. b is 2. M is 3. If we're writing an equation, y equals mx plus b, we're just plugging those in. Y equals 3x plus 2. What two variables should you always have in your final equation? X and y, unless it just happens to be a vertical or horizontal line. Okay? The two things you need to know then every time is?
M and B.
M and B. Okay? So if I took a look at this one, do they give us M and B for number 9?
They gave us M.
They give us M. We need to find
B.
B. We don't know B. So we use our equation, y equals mx plus b. If m is 2, we get y equals 2 times x plus b. Well, what is this point?
2 and 2, 4.
2, 4. That's an x and a y. So what we can do is use those. If we know an x and a y on this line, we can put those points in for y and 2 for x. Okay, so rather than using m and b, or m and then x, y to find b and then plugging that in, we could use this right here and use point slope. So point slope, y minus y1 equals m times x minus x1. All right, this is your x1 and this is your y1. Y minus y1. Y minus what? 1 equals m, which is negative 1, times x minus x1, or negative 3. Notice if you don't put it in parentheses, you might miss that that's a double negative, which actually means positive. So you have negative 1 times x plus 3 there. Distribute. You get y minus 1 equals negative x minus 3. What do we do now to get y by itself? Add 1. Y equals negative x minus 2. That's our equation. Okay, so you have two different methods. You could use point slope form, or you can use your slope and the point to find b and then write it. It's up to you. Your assignment is